Hello, everybody. My name is Sean. I'll be joined by L, Jack, and Jacob as we go over the ggplot package in R. First, let me turn off my camera so it's less distracting. All right, so what is ggplot? It's a dynamic R package that specializes in data visualization, stands for grammar of graphics, which is due to the syntax that you have to learn in order to get graphics up on screen. It uses the layered graphic system, which is essentially creating your own canvas and then adding each piece of information on it yourself by layers. It's been around for a while. It's been around since 2005, and it's been really available for everybody. So everyone has kind of tweaked it and made offshoot packages on their own in order to just better the community. And it's the cornerstone of the Tidyverse package, which is an EDA tool in R. So enough talking about it. Let's actually see it. So here we're going to use the MPG data set, which comes with ggplot. We're going to focus on the displacement, highway miles per gallon, and we'll factor things by class of vehicle. And here's the code that you would originally have made for a base R plot. And it looks okay. We can see a trend here as displacement increases as the miles per gallon goes down, and we can kind of see the impact by each class of vehicle here. Notice just where the legend is and kind of how the colors look and the what went into the code as well. But here's the same exact model with ggplot. Let's see how that looks. And that is, in my opinion, just a lot more clean, crisp, and I'm able to discern a lot more information out of this just by looking at it much quicker than I did with the original. I also like how the legend is off to the right and it's not part of the actual canvas here. It actually gives it room to breathe. Here's another example. By just changing one aspect of the aesthetics here, I put the color in a different location, and I add a geom smoother. I'm able to get smooths for each class of vehicle, and it also adds it immediately to my legend. So I think you get the point. ggplot is crucial for machine learning and data science just by the power of visualization itself. Sorry to be cliche, but we've all heard the phrase, a picture is worth 1,000 words. Well, it's true here. And especially during EDA, when you're able to see your data more clearly, you can make faster inferences, quicker decision making, and ultimately start solving problems more effectively when your story is told through your data. ggplot is highly dynamic and simplistic. We'll give examples of how, but you'll see that's just less typing. There's more thinking, and just it turns that complex data that you have into just powerful visuals, as you just saw. There are some limitations, however. Just like with every language, when you're starting to learn it, it can get a little complex, and the rabbit hole of ggplot is not lacking in that regard. So we gotta kind of tailor it to what you need done. That being said, sometimes it might be too much for a job too little, where your point might be just a simple scatter plot to showcase to somebody, and it doesn't need to look so as glorious as ggplot can make. So I call it just killing an ant with a bazooka. So pick your battles and do what needs to get done, and just do it smartly. But ggplot can help tell the story of your data. And how are we going to do that? What we're going to do is we're going to juxtapose it with material that you've learned in Stat 410 and Learning R. We're going to do that by first showing you the fundamentals of the grammar of graphics. We're going to go over histograms, kernel density, and scatter smooths, and then we'll go over some regression visuals.
Jumping into the basics, I'll go over the install, a few of the syntax pieces, mainly the data and aesthetics portion, and then I'll introduce what geoms are. So to install and use the package ggplot, you have to include ggplot2 when installing and initializing the library. However, the actual function will just be called ggplot. Now, ggplot as a function takes data frames and not vectors. So here I'll just throw in the water data set from our textbook, and this will create what's just called the canvas. So it's just ggplot is initialized at this point. That's the data statement. Now the AES or aesthetic statement, it changes based on which geoms you're going to use, but here I'll just throw it an X and a Y. And so it creates an X and a Y axis based on those two variables. Now is where we start doing the actual data visualization. So here I'll literally add with a plus sign, a geom statement. And this X here stands for different things. So if you want a scatter plot, it's geom point, histogram, hist, and then box plot is self-evident. If you don't know what geoms are available, it's easy. Just type in geom underscore and then tab, and then you can see a bunch of different options that are available with ggplot. So here I'll make a scatter plot by just using that aesthetic statement from earlier, and then just simply adding a geom point, and that makes a really simple scatter plot. You can put the AES statement in different portions. Here I put the AES inside the geom point because I can layer at different points, and I'll show you that in 1 second. So that's the same exact statement. And down here, I'm just going to literally add another layer here. I'm just going to add a hexagram and see what that does. And it's not really useful, but you're seeing here how it's adding different pieces of visualization on top of your canvas that you created. So now we have little hex plots, and they show different values. Here, one more example. Just going to add a box plot. So once again, not useful, but maybe it is in some way. We could tell the higher mortality here lower, but it's on top, and there's probably a way to change it. But just showing you how you add these geoms with aesthetic statements that stem from your data statements in order to produce visuals. Now, each of the group members are going to explain which geoms they're using in order to produce these graphics, and I'll pass it off to them.
Hi everyone, my name is Elle. I'm going to be talking about Ggplot histograms. So let's get started. In order to do this, I first wanted to start with a comparison between base R histograms and Ggplot histograms. So here we have a very basic histogram using base R, the hist function. To do this, I used the iris dataset that's built into R, and I wanted to look at the sepal.length variable within that data set. So here we have it. It looks good. It tells us some things about the data set, although this is pretty much the best you can get with base R. There isn't much else that you can get from the data using this function. And that's how Ggplot comes into play, because it can tell us a lot more about the data. And it's also very customizable. So first, in order to use Ggplot, of course, we need to make sure that we're bringing in Ggplot into memory using the library function. And then the only other thing is that we have to use data.frame for our data set in order to create a data frame for Ggplot to be able to use it. So for comparison's sake, I made the exact same histogram using Ggplot and just to compare. And they do look pretty much the same, although they have the grid using Ggplot does have a grid behind it. But that's just to emphasize the fact that this is the very basic plot using Ggplot, and there's a lot of other cool things that we can do to add on to this. So let's go into those bells and whistles. So first of all, I want to emphasize the customizability of the Ggplot histograms. We can customize the color. So for the first plot, I customized the fill color and the outline color. So I used blue for the outline color and green for the fill color. I think it looks cute, but you can customize the colors to whatever you need. And then I did the same thing with purple and pink. So that in of itself is pretty cool that we can do. Another thing that we can do, this is probably my favorite thing that we can do using Ggplot, but I wanted to see if there was any relationship between sepal length and species within the data set. So within the AES function, I specified I wanted the colors based on the species. And as it turns out, Virginica has higher sepal lengths compared to Setosa, which has shorter sepal lengths. And that's a really cool thing that we got from the data using Ggplot that we weren't able to get before using histogram or base R histograms. So I think that's really cool that you can look at another categorical variable and see the different sepal lengths within that. Beyond that, we also can do a gradient effect on it, which is really cool. For this gradient, I did a light blue for the lower frequencies and a dark blue for the higher frequencies. And then it does the cool purple for the more moderate frequencies. And I think that's really cool because it allows us to clearly tell the different frequencies throughout the data set. And we can see that the higher sepal lengths tend to have lower frequencies compared to over here and over here. I also wanted to look at a histogram, create histograms for each one of the species. So I was able to do that using the facet_wrap function, specifying the species. And by doing that, I am able to clearly see that the Virginica species has higher sepal lengths compared to the Setosa, which is similar to what we saw in the histogram previously, although instead of having them overlaid on top of each other, they're separate. So these are just a few of the really awesome things that we can do using Ggplot. It's very customizable. It allows us to see things more clearly within the data and specify things within the data, which I think is really awesome. It's a really awesome tool for you all to be able to learn how to use, and we can do so many things just by adding another function. So thank you all for listening. I hope you all learned something, and I'll pass it off to Jack for scatterplot smoothing.
Hi guys, I'm Jack, and I'm going to be going over density estimation and scatterplot smoothing in Ggplot for you guys. So let me share my screen and we'll get going. Alrighty, so today we're going to be looking at NFL Combine data from 2000 to 2018. Let me turn that off. And so we're going to be looking at is players' weights versus their 40 times. We'll be looking at weights for the density estimation and then 40 times for comparison versus the weights. So quick summary statistics on this. We have a mean weight of around 252 pounds, which, as we'll see, is going to fluctuate depending on what position the player plays, which makes sense. And then also our mean 40 times of 4.78, which is going to vary between low 4s and high 5s. So we're going to start with just a simple density plot comparing base R versus Ggplot. So base R, as we've done this semester, does a decent job, but without changing any settings. You obviously already missed the third peak without changing anything. And Ggplot, all we need here is the geom density, which, as you can guess, does a density estimation for x variable weight. And geom v-line, as you can also guess, does a vertical line wherever you put the x-intercept, in this case, the mean of weight. So let's run that. And as you can see, it does a very, very nice job, very aesthetically pleasing, and it actually gets all of our peaks. So with our variable weight here, we have three different peaks. The first peak is around 200 pounds. So in this sense, what that means is that skill positions like wide receivers and running backs are going to be in this region. And then our next peak is around 250 pounds. So that's going to be linebackers, fullbacks, strong safeties. So there's a bunch of people in that region. And then the last peak is around 310 pounds or so, which is where we're going to have our offensive and defensive linemen. So it makes sense that there's three different peaks. And then we have the vertical line at around 252 pounds, which is our mean weight. So moving on to kernel density by team. This is where we really start to get a sense of how powerful a Ggplot is. So manually here in base R, I picked just 3 random teams. Saints, Jets, and Cardinals did density estimation for their weights here. And as you can see, it's a lot of coding and it's just a lot of extra work compared to Ggplot. Here we have the argument color equals team and then our geom density again. And as we can see here, this runs a density estimation for every single team, all 32 teams, gives us a great legend, all 32 teams, without us having to do any extra work. And it's actually very helpful, as we can see here, for an EDA perspective, because here we have the Los Angeles Rams that have a much higher peak right here, and then the Los Angeles Chargers who have an interesting pattern right here. And so from an exploratory data analysis standpoint, we can see that these two teams don't really follow this trend the rest of the NFL has, which means that they probably had different needs than the other teams, which would be interesting to look at in a more in-depth research on these perspectives. So now we're gonna move on to contour plots. Here we have very simple geom density 2D filled is the function we need to create this. And then geom density 2D are the points that we have here. And as you can see, it does a great job. Just color coordination gives you another great legend on the right over here on what density coordinates with what colors. And as you can see here, around 200 pounds and a 40 time of 4.5, we have a very high density, around 250 and a 40 time of 4.65, and then weights of 310 pounds and a 40 time of 5.2. So as you can see, as you would guess, as weight increases, so does 40 time. And this plot does a very good job at showing not only the trend, but also where a lot of the data lies and where most of the group lies and where the outliers are. So it's very, very helpful to look at from an EDA perspective. All right, for our last example, we're going to look at the actual water data set that we had looked at earlier this year. So for our base R scatterplot smoothing, as we've done before this semester. A lot more coding than what we need for Ggplot. Also, not that great of a graph aesthetically, not really very nice to look at. Ggplot, all we need is one line here, and here we go. We have geom smooth, our function geom smooth, color equals location. Great, beautiful graph, 95% confidence intervals for each scatterplot smooth. Another legend without us doing any extra work. So Ggplot just has the ability to make our lives a lot easier and also create better graphs, which is the name of the game when we're trying to explain our findings to people that don't really understand what's going on. So that would be, let me go back to the screen here. So that would be our quick overview of kernel density estimation and scatterplot smoothing in Ggplot. And now I'll pass it off to Jacob. Thank you.
All right, what's going on, guys? My name is Jake, and I'll be going over how Ggplot can improve our EDA of regression. So the data set we're going to be using is the same one we used in Lab 9. So that's the real estate CSV data set. And the setup is the exact same thing. So we have our transformations for the train and test subsets, and they're the exact same as in Lab 9. And then the libraries are all the same, except obviously we're going to be using Ggplot. And now let me turn off my video camera so it's not as distracting. All right, so one of the graphs I chose to display was our predictors versus residuals, which is kind of one of the tests we do for normalcy. So this is the normal way we do it. But you're actually able to add a lot of vibrancy and detail through Ggplot. So let's go ahead and get started and see how that works. So we're going right here. So first off, you start with Ggplot. Obviously, we're going to use our fitted model, which is the same thing as in Lab 9, and then our X, which is our predictors, and our Y, which is our residuals. And for the color, we do something a bit interesting here, and I'll get into this. This is actually going to be our residuals, a continuous kind of weird kind of continuous color variable. And then we want points, and we want a line going through the middle, same as the plot above. And we added a smooth just to make sure we don't have any weird hidden correlation going on, so we can evaluate that. And then our axes. And finally, this part is what I wanted to highlight right here. So we have all of our Ggplot stuff so far, plus scale color gradient 2, which actually, what this does is it allows you to specify a midpoint, which is going to be 0 in this case, a low point, and a high point. So what that means is the color gradient is going to go from red to green to red as we travel up in studentized residuals, giving us a very clear indication of which residuals are kind of far away from the rest. So if we go ahead and run that, we can see right here that our super far residuals that are outside of 3 standard deviations are very red, and our ones in the middle are green. So I really like this green to red representation for most of these graphs, actually, because it gives you an idea with the really red values, where your outliers are. But overall, the graph looks pretty good, as we already know, and the smooth doesn't indicate any weird correlation. Okay, so now moving on to Cook's D. This is our normal Cook's D plot down here. It looks pretty good, but we can improve upon that with Ggplot, and I'll show you how in a sec. So we're going to do Ggplot, our fit, and then sequence along Cook's D of our data. Basically, this just means our observation number is essentially what this means for our Cook's D. And then the Y, this means our Cook's D for our data. Color is also going to be Cook's D because we're going to create a gradient as well. And then we can also change our column width if we desire for our bars for our Cook's D, so they're not quite as skinny as this one up top. And then we want to do scale color gradient as opposed to scale color gradient 2 like we did for the last one. So for this one, we just want to specify low and high. So I do green and red again, which is, I think, two really good colors to go for that gradient, because you can just tell very easily where your outliers lie. And then obviously our axis labels. So when we look at it, we can see very clearly where our outliers lie. Obviously, it's clear in this one as well, but when you get some of these ones that are a little bit more ambiguous, it helps to have the color there as well. So in terms of effectiveness, I'd say this one's a little bit better. I wish it gave you the outlier numbers here without having to specify like in this one or like in the top one. But in terms of just flashiness and color, I prefer this version of the Cooks-D. As you can see, our gradient is kind of, it works very well for identifying the outliers here. And now we're going to pass it back to Sean for our conclusion.
Well, there you have it. We went over Ggplot basics, histograms, densities, scatter plots, a little bit of smoothing, and we saw some regression EDA visuals. We hope that we illustrated the importance that Ggplot has on not only R, but the whole of data science as a community. So thank you very much for watching, and we hope you learned something. Thank you.